Good morning, students. Today's topic in the subject of chemistry O-level is molar mass. So this is a technical topic, so concentrate yourself. We are going to start now. The mass in grams of 1 mole of a substance is called its molar mass. So this is the definition of the molar mass. The molar mass of any substance is always equal to its relative formula mass in grams. So look now, molar mass is always equal to relative formula mass in grams. And here are three types. The mass of 1 mole of the atoms. So atoms is equal to relative atomic mass. The mass of 1 mole of molecules. So molecules is equal to relative molecular mass in grams. The mass of 1 mole of units of an ionic compound, so ionic compound is involved, is equal to its relative formula mass in grams. So if atoms are involved, relative atomic mass, molecules are involved, relative molecular mass, and if ionic compound is involved, relative formula mass. So look now, we are going to do some examples. So these are very simple examples. So look at the pattern. One question's pattern will be followed in the next one as well if the question of this type comes in the paper. So look now, relative atomic mass of the magnesium, that is 24. We can find it from the periodic table. Hence, the mass of 1 mole of magnesium atom is equal to 24 grams. So here is relative atomic mass. But here is mass of 1 mole, so that's why gram is placed. And now that is molar mass of magnesium is 24 grams per mole. So we will put the unit grams per mole with the molar mass. And if only the mass of 1 mole is given, that will be in grams. And if the relative atomic mass is given, that will be in 24. So this same pattern will be used in the next question as well. The relative molecular mass of the ammonia is this 17 because N is 14, H is 1, so 1 3s are 3 plus 14 will be equal to 17. Next steps will be same, hence mass of 1 mole of the ammonia molecules is 17 grams, so gram is put now with it. That is molar mass of ammonia is 17 gram per mole. So look here gram and here gram per mole is put with the 17. The same method will be used over here. Relative formula mass of sodium chloride. So sodium is 23, chlorine is 35.5. So 23 plus 35.5 will be equal to 58.5. So this is relative formula mass. Now mass of 1 mole of the sodium chloride, gram will be put with it. And now the molar mass of the sodium chloride, gram per mole will be put with it. And other question, same pattern will be used. Relative formula mass of the nitrate ion, so that is 62. Hence the mass of 1 mole of nitrate ion, gram will be put with it. The molar mass of nitrate ion, gram per mole will be put with it. So now concentrate, some more things are going to be read in the lecture. If the substance is oxygen atom, definitely the formula will be O. Relative formula mass is 16. Mass of 1 mole of the formula units is 16 grams. Gram is put with it. And the number of particles in 1 mole is 6 multiplied by 10 raised to the power 23 O atoms. But now look, concentrate. Oxygen molecule. So oxygen molecule is O2 because O is 16, so 16 2s are 32. This is the relative formula mass of O2. Mass of 1 mole of the formula units, so gram will be put with it. And now because 2 O are there, that's why number of particles is 2 into 6 multiplied by 10 raised to the power 23 O atoms in O2. Look now, calcium, that is Ca. Relative formula mass is 40. Mass of 1 mole of the formula unit is, gram will be put with it, that is 40 grams. And number of particles in 1 mole, 6 multiplied by 10 raised to the power 23 calcium atoms. Now calcium ion, that is represented by Ca2+. Relative formula mass is 40. Mass of 1 mole of the formula units is 40 grams. And number of particles are 6 multiplied by 10 raised by 23 calcium ions. This thing is important. Concentrate now. Lead iodide. Formula is PbI2. Relative formula mass is 461. Mass of 1 mole of the formula unit is 461 grams. Now look, because this is one molecule, that's why 6 multiplied by 10 raised by 23 PbI2 units are there. In one molecule of the lead iodide, there is one lead atom. So that's why, because one lead atom, 6 multiplied by 10 raised by 23 lead ions. But there are two iodide ions. So that's why 2 into 6 multiplied by 10 raised by 23 iodide ions. So concentrate. Okay, the next thing which we are going to read is to convert moles to masses. Use the following formula. The formula is mass of the substance is equal to number of the moles of the substance multiplied by molar mass of the substance. So mass of substance is equal to number of moles of the substance multiplied by molar mass of the substance. Now we are going to do some questions that will explain the formula. Calculate the mass of 2.5 moles of the sodium atoms. Look now, moles are given and the mass is the requirement. First, we will find the molar mass of the sodium atoms that we can check from the periodic table, that is 23. So the molar mass of the sodium is, just put grams per mole with it, that will be the molar mass, because grams per mole is the unit. So grams per mole, 23. Now we are going to apply the formula. Mass of the sodium atom will be equal to moles multiplied by molar mass. So moles given in the question are 2.5 and molar mass we have find out, that is 23. So multiply on the calculator. Now look into the unit. This mole will be cut with it. Only gram will be put with the answer. So this is the answer. And other question. Calculate the mass of 0.8 moles of the nitrogen dioxide molecule. First, we will find the molar mass. So first, relative molecular mass. Nitrogen is 14, oxygen is 16, so 16 into 2 plus 14, that will make 46. So 46 grams per mole is the molar mass of nitrogen dioxide. Now the formula will be put, mass of NO2 is equal to moles multiplied by molar mass. Moles are given 0.8 and molar mass we have find is 46 grams per mole. So multiply on the calculator, that will be answer in grams. And other question, calculate the mass of 4.6 moles of the potassium hydroxide. So first we will find the relative formula mass of KOH. K is 39, O is 16, H is 1. So adding them will make 56. So 56 gram per mole is the molar mass of KOH. Okay, now we will put the formula. Mass of KOH is equal to moles multiplied by molar mass. Moles are given, that is 4.6, and molar mass that we have find out is 56. Solve it on the calculator. This is the answer. Gram is the unit. Look at the other form of the formula. Actually, this is the original formula. If we leave the moles here, this molar mass will go to the denominator of the mass. So look at the formula. Number of the moles is equal to mass of the substance over molar mass of the substance. So this is the alternate form of the previous formula. So number of moles is equal to mass of substance over molar mass of the substance. Look now, this alternate form of the formula will be applied in some questions now. Calculate the number of the moles of these atoms in 9 grams of the scandium. So mass is given. First, okay, relative atomic mass of scandium is 45. That is that we have find out from the periodic table. So molar mass is 45 grams per mole. Now we will put the formula, that is moles of the scandium atom is equal to mass over molar mass. Because mass is given, that is 9 grams, and molar mass is 45. So put the values into the formula, solve it on the calculator, answer will be in moles. And other question, calculate the number of the moles of the molecules in 66 grams of the carbon dioxide. So first we will find the molar mass of the carbon dioxide. So first the relative molecular mass. Carbon is 12, O is 16, so 16 twos are 32, plus 12 will make 44. So molar mass of the CO2 is 44 grams per mole. Now the formula, moles is equal to mass over molar mass. So moles will be equal to mass. Mass is given 66, will be put in numerator. Molar mass is 44. So solve it on the calculator. This will be the answer. And other question, calculate the number of the moles of calcium carbonate in 240 grams of the calcium carbonate. So first we will find the molar mass of the calcium carbonate. So first relative formula mass, calcium is 40, carbon is 12, oxygen is 16, so 16 threes are 48, plus 12 plus 40 will make 100. So molar mass of the calcium carbonate is 100 grams per mole. Now the formula, moles is equal to mass over molar mass. Mass is given, that is 240 over molar mass is 100. Solve it on the calculator. This is the answer. Okay, here is another question. Calculate the number of the moles of each element present in 1 mole of each of the following substances. So this is the substance. So 2 substances are given, and the requirement is the number of the moles of each element. So in first element, if you look carefully, there are 2 moles of the nitrogen are present. So look now, 2 moles of the nitrogen, 4 twos are 8, 8 moles of the hydrogen. So look now, 8 moles of the hydrogen. Chromium is Cr is 2, so 2 moles of the Cr, and O is 7, so 7 moles of the O. So this is the solution of the first part. Now look at the second part. There are 3 moles of the magnesium, 2 moles of the P, and 8 moles of the O. So this is the answer. Here is another question. Calculate the number of the moles of each element present in 1 grams of each of the following substances. So here is a substance. First we will find the molar mass. So relative formula mass of the Na3Al(F6). So this is the relative formula mass. So the molar mass of this substance is 210 grams per mole. So now the formula is moles is equal to mass over molar mass. So here is the mass 1 grams and molar mass is 210. So solve it on the calculator, you will get this answer. So look now, requirement is to calculate the number of the moles of each element. So sodium is having 3 moles. So look now, there are 3 moles of the sodium atom, aluminium 1 atom, and F fluoride is 6 moles. So just multiply the moles with this value. So 3 into 4.8 multiplied by 10 raised to the power minus 3 will be equal to the number of the moles of sodium atoms in 1 grams of the substance. Likewise, 6 will be multiplied. Sorry, first aluminium. So 1 will be multiplied with this one, will give you the number of the moles of the aluminium atom in 1 gram of this substance. And likewise, 6 will be multiplied with this one to give you the number of the moles of the fluoride atoms in 1 grams of this substance. So same method will be used in the second part as well. So here is the question. You may see and now solve it on by yourself at home and tally the answer. Okay, the next question is determine the mass in grams of the following 1 molecule of the water. So look now, relative molecular mass of H2O is 2 into 1 because H2O and plus O is 16. So this is the relative formula mass, molecular mass of the water. So molar mass of the H2O will be 18 grams per mole. Now we are going to put the formula of the moles. So number of the moles will be equal to number of the molecules over 6 multiplied by 10 raised to the power 23. Because number of the molecule is 1. 1 molecules is the given. So 1 over 6 multiplied by 10 raised to the power 23. This is another formula of finding the number of the moles. So this is the number of the moles of the H2O. Now we are going to find the mass of the 1 molecule because this is the requirement. mass of the one molecule. So mass of the one molecule of the H2O will be equal to mole over molar mass. Sorry, mole multiplied by molar mass. So moles are 1 over 6 multiplied by 10 raised to power 23 and molar mass is 18. Solve it on the calculator, you will get the answer. B part is 10 moles of iron nitrate. So very easy. First you will find the relative formula mass, that will be equal to the molar mass of the substance, same amount, but unit is gram per mole. Now 10, because this is the mass of the 1 mole. Now we are going to find the mass of the 10 moles. If mass of 1 mole is this, so just multiply this number with 10, you will get the mass of the 10 moles. So this was the lecture, students, one of the important lectures in the topic. So read this lecture again, learn it, practice it, and make your notes. Thank you so much.